Hello everyone, welcome back to my YouTube channel A for Analysis, where we talk about a lot of machine learning projects and how to implement them using Python. Today we have a very interesting assignment in hand. Unlike any other projects that we have done in this channel, today we'll build something from scratch. We will not use anything which is predefined in Python. We will not use scikit-learn. Rather than that, we will use our intuitive knowledge in machine learning to build a decision tree classifier from scratch. So that's the problem statement for today, to build a decision tree classifier using Python. Now, before getting into the technical details of this code, I would suggest all of you to go and check your decision tree classifier intuition, and once you are clear with the intuition, then only you come back and watch this video. That will help you to understand the code even better. Now, without further ado, let's start with the code. So first of all, we have imported all the modules that we will be needing, and we have implemented it as a class. The decision tree classifier has been implemented as a class, and all the things that we have in scikit-learn decision tree classifier, we have also tried to implement them using different methods of this class. So the first one is init, of course, where we have initialized all the variables that we will be needing throughout our implementation. Now, this is something which I started with few things which I was sure like these things will be definitely needed, like for example y and x, definitely we need them. And as I started working on the problem statement and I came across few more things are required, I kept on adding those things, and this was the final list of things I needed for the entire code to run. So these are the things we need. As you can see here, y and x, I didn't keep any value, so you have to pass them. For all the other attributes, I have given the default value. So in case you are not giving any value while initializing the object, these values will be used for the decision tree classifier. As you can see, by default, the node type will be root. And criteria, this is Gini or entropy. We'll see that in a few minutes. So here, as you can see, we have also kept min sample split, max depth, all these things. Now this is for hyperparameter tuning. You can also make even simpler decision tree, but I had to make this because why not do something a little bit advanced than just the simple one. Now let's move on to the main functions that we need for this. So for a decision tree, which is a collection of conditions basically, and based on those conditions we are splitting the nodes and we are separating the zeros from ones, the yeses from no's, and so on. So for doing that, we need to use a criteria, be it Gini index or entropy. So I have defined a method get Gini or entropy. This is basically for both of the criteria. So whatever is the criteria, it will return for a particular node, it will return the Gini impurity or the entropy. Now, if you have already brushed up your knowledge in Gini impurity and entropy, you would identify this very easily, that how the Gini index is calculated and how the entropy is calculated. So this is just the Python implementation of that. Next, we have determine best split, which is nothing but where we'll check for each feature and each value, which is the best value to perform the split and which is the best feature for performing the split. So whenever we have to split a node, we have to take a condition. which is some feature has to be greater than or less than some value. So what will be that feature? We will call it as our best feature for split, and the threshold value which will be used for the splitting is called as best threshold throughout this code. So here we have taken the best feature and best threshold, and what we are doing here is we are traversing through each of these features, and we are also taking the thresholds, and for each threshold we are dividing the parent node into two nodes. One is left node and one is right node. Left node is nothing but where the values are less than threshold, and right node is the one which has greater than equal to threshold. Next, we are calculating Gini or entropy based on whatever criteria we have selected. So here the Gini or entropy will be calculated for both of the nodes. Then we are also calculating the size of each node, the left node and the right node. This is important to do because we also want to calculate the weight afterwards. So that's what we are doing. Right next to the size calculation, then we have the weighted Gini or entropy, which is nothing but we are taking weighted Gini, means for every node, the weight means the size of that particular node by the size of the parent node. So if you can see one of the weights, let's say for example here we have left node weight, which is left node size by left node size plus right node size. This means the parent node. So this is, I have tried to keep the namings as simple as possible so that it matches with your intuition as well. So here, as you can see, we are getting the weights, and after we have the weights, we are just multiplying with the corresponding Gini or entropy of that node, and with the summation we are getting the total Gini or entropy after the split. So before the split, the Gini or entropy will be the Gini or entropy of the parent node, and after the split, the Gini or entropy will be the weighted sum basically. So here, after that, we have to calculate the information gain. Information gain is calculated by subtracting the weighted Gini or entropy from the base Gini or entropy. Base Gini or entropy comes from the parent node's Gini or entropy, and we are subtracting the weighted Gini which comes after we split the node from that. So this is the Gini or entropy before the split, and if we perform the split, what is the weighted and what will be our information gain. So here the idea is to find the feature and the corresponding threshold value for which the information gain is the best, information gain is the highest. So wherever we find the information gain is highest for all the threshold values and all these features, that particular feature and that particular threshold will be selected as best feature and best threshold and will be used for the splitting. Next is build decision tree, which is basically where we grow the tree. So this will be a repetitive process, like first we start with the root node, then we find the best feature and find the best threshold, we divide it once, and we have to repeat this process again and again unless we end up with a lot of leaf nodes where we have the zeros and ones separated or the labels are separated, like so. So build decision tree is nothing but where this repetitive process takes place. So here, as you can see, we have kept a condition. So when we should stop, we cannot do this till infinity. So yes, we have to keep a logic for that. Here the logic is unless the depth of the tree is still less than max depth and the size of the node is greater than mean sample split. If you know about the hyperparameter tuning, you would know about these things from decision tree perspective as well. So these two are our stopping condition for growing a decision tree. So unless this is true, till that time we will continue this process. What is this process? Here we have two nodes, one is left DF and one is right DF. Here we are just dividing the data between two sides. As you can see here, the less than equal to is taken in left node and the greater than is taken in right node. So for left node we are creating the object of decision tree classifier because we are repeating the process again. Like how we did for the first time, we are taking a condition, we are getting the best feature and best threshold value for that feature, and we are dividing the root node in left and right. And those left and right nodes have to be further splitted into smaller left and right nodes, right? So that is the process happening in this function. So first we are initializing the object decision tree classifier, and then we are again calling the build decision tree, which will try to grow the left side of the tree. So first left node that we got, that will be further divided into number of left nodes and number of right nodes. Similarly, the first right node that we got, that will be further splitted into many right nodes and left nodes. So that's the process happening here. It's nothing but making the object of the same decision tree classifier. Only thing is here we are supplying a different part of the data set. So here we have taken what was less than the threshold, and here we have supplied what is greater than the threshold, as you can see here. So this is the y and this is our x, and we still have the conditions in place, and criteria is also supplied along with that. Next function that we have here is the predict. Predict is similar to what we have in machine learning. It will just predict the value of y given x. So that's what we are trying to do here. When the current node's depth is still less than the max depth, so this is the condition till the time it should predict, till the time it should continue. Once this condition is false, it shouldn't continue. So that's what we are checking here. We are giving it the best feature and best threshold. And next thing we are doing is, if the feature value here, this will give the feature value actually. So if the feature value comes out to be less than the threshold, so we are deciding the current node is actually left node. And if it is greater than equal to the right node, the threshold, sorry, if it is greater than equal to the threshold, then the current node will be a right node. So once we are getting that, we are just getting the ypred, which is, we will show it from the top, which is nothing but the predicted value for that node. So we'll come to that in a moment. This is the last function, which has nothing to do actually with the main decision tree classifier logic or algorithm. It is just for showing it nicely how the splitting happens and what are the conditions, what were the best features selected. So for that I have kept a function, but this is not really important for the decision tree logic. So the only thing which I haven't talked about is this ypred. So we'll go to the top where we have the ypred. So here, as you can see, ypred will be nothing but count sorted. We will take the y counts. So since this is a binary classification and there will be zeros and ones, so from that we will count whichever has greater value, that will be our ypred. So basically, if a node in particular has 5 ones and 4 zeros. So we are sorting that first, and after sorting, since 1 has greater number of occurrences, so 1 will be the vibrant. That is the intuition behind this. So more or less this is the decision tree. I would just explain the very simple example that I took at first. This is for odd even classification. As you can see, it's binary digits, so 0 to 15 we have here, and y is nothing but if x is even it is 0, if x is odd it is 1. So very simple thing, and I have tried to use decision tree for this, as you can see here. And first we got root node, and we have entropy of 1, class distribution, we have 6 zeros and 6 ones, and predicted value is 1. And splitting rule here is x0 less than 0.5. So as you can see, we have to select the best feature, right? So if you look at this, you will understand that y is actually exactly similar to x0. So we can tell this just from our plain vision. But the same thing has been caught by the decision tree classifier as well, that x0 is the most important feature for the split, and the threshold value it used is 0.5, and based on that it's able to classify all the values correctly. And you can see that the training and test accuracy is very good. This was a very simple example. I have taken the spam dataset after that, which is another dataset, very popular dataset, which has a bunch of features, numeric features, and the target variable is 0 or 1, which means if it is a spam or not. So I have taken this spam dataset as well, and I have shown here with criteria Gini and mean sample split 2, max depth 5 here. And I have also shown here another one where I have used criteria entropy, and I did the same thing. And at the last I have also printed the accuracy score as well. So that's about the decision tree implementation in Python from scratch. I think one small thing I would also like to mention is this moving average. This moving average is nothing but a function which will return us a bunch of values. This we created just to get a list of thresholds. So where we are selecting the best feature and best threshold, here it will be useful. You can just use this function, use a small x and window of your choice, and you can just print this value and you will understand it very well how it is working. So yeah, that's it for the decision tree classifier, guys. I hope it was helpful for you, and if it was helpful for you, please do give it a like, subscribe, and share it with your friends if they are also following up with machine learning. So that's it for today, guys. We'll meet again very soon. Bye, guys.